In this problem, we want to find all relative extrema and points of inflection. So we got f of x is equal to x to the fourth minus 4x squared plus 2. We need to find our first derivative. So f prime is going to equal to 4x to the third minus 8x, and then 2 drops away. Well, we'll also need our second derivative, so let me go ahead and find that right over here. So take derivative of this right here, and we get 12x squared minus 8. Okay. Now back to our first derivative here. This first derivative test. We want to set that equal to 0. So we got 4x to the third minus 8x equal to 0, and factor it. Well, first thing I noticed is they got a GCF. They're both divisible by 4, and they both have an x. So that gives us x squared minus 2 equal to 0. Set each factor equal to 0, 0 factor property. 4x equal to 0, and x squared minus 2 equals 0. Divide both sides by 4, and we get x equals 0. Here, I'll take the negative 2 to the right side, becomes a positive 2. Drop our squared, and put a plus or minus square root around the other side. So we're going to have x is equal to negative square root of 2. Clear over here is negative infinity. Then our next critical value is 0. And our next one is positive square root of 2. And then clear over here is positive infinity. Now we want to choose test cases. I want to choose something between, boy, that seems weird how that came out. It didn't come out nice at all. Let me double check myself real quick here. Yeah, that looks right. Okay. We want to choose something between negative infinity and negative square root of 2. Now, negative square root of 2, that's negative 1 point something. So let me put in negative 3. We want to choose something between negative square root of 2 and 0, like negative 1. Something between 0 and square root of 2, like 1. And something greater than square root of 2, like 3 or 4. Now we will plug those into our first derivative. Our first derivative is right here. I'm not sure if I really want to think that hard this morning, so let me just use my calculator. Now, first thing I'm going to do is I'm going to go to y equals, do a clear, y equals clear, and I'm going to put my function on f1 or y1. So we got x to the fourth, so I'll do x caret 4. Press your right arrow key if you go in the newer T84s to get out of exponent mode. Minus 4x squared plus 2. And I'm going to down arrow. I'm going to put my first derivative on y2. First derivative was 4x to the third minus 8x. And just in case I need it, I'm going to put my my second derivative on y3, 12x squared minus 8. So 12x squared minus 8. Okay, so function, first derivative, second derivative. Now I'm going to go into my table setup, make sure everything's correct. So I'll do second window. Under independent, it should say ask. If it doesn't, down arrow to that line, right arrow, put your flashing cursor on the ask, and press enter one time. Now if I go to second graph and press delete, we're going to plug in these. So I got negative 3, enter, negative 1, enter, 1, enter, and 3, enter. Now negative 3 gave us a negative 3 gave us positive 47, so this is increasing. Negative 1 gave us a negative 1, which means it's decreasing. And 1 gave us negative 1, which means it's decreasing. And 3 gave us positive 47, which means it's increasing. Now, what I'm looking at is I'm looking at y1, because that's where I put my function. Oh, wait a minute. I should be looking at y2. Don't create these early in the morning. I'll wake up eventually. Okay, y2 is where we put our first derivative. Sorry. We're plugging negative 3 in, we get negative, so that's decreasing. Put -1 in, it's positive, so it's increasing. Put 1 in, it's negative, so it's decreasing. And 3 in, we get 84, which means it's increasing. Because remember, this is the first derivative test. We plug in our critical values into our first derivative. Okay. That means that we're going to have a, this is decreasing, changes to increasing, so this is a min. This changes from increasing to decreasing, so this is a max. This changes from decreasing to increasing, so this is a min. So we're going to have a min at -2 comma something. We'll have a max at 0 comma something. And we'll have a min at √2 comma something. Now we want to plug those back into our original function, which is this right here. Now if I plugged in, let me see, the -2 and 0 and +2. Our original function was y is equal to x⁴ minus 4x² plus 2. Now what we're going to find is that in this problem, this works out really nice. So I plug these in here. When I say it works out really nice, we can actually use our calculator for this. So come back over here. I'm going to go let me clean these out. So press delete on those. And we want to enter -2, so negative second x² and 2. Enter. And then I'll put in 0. Enter. And √2. So do second x² and then 2, and then enter. Now the y1 is our function. So this one's going to give us y is equal to -2. The next one is y is equal to 2. And the next one is y is equal to -2. So this would be -2, this would be 2, and this would be -2. They don't always work out nice that way. If this had been the third power, then we would have had to get the exact answer. We'd have to go through and do it by hand. Okay, now POIs. Well, we're going to set this equal to 0, so 12x² minus 8 equal to 0. And solve. So take -8 to the right side, becomes a +8. Divide both sides by 12, and we get x² is equal to 8 over 12. Which reduces, both divisible by 4, so that gives us 2/3. Square root property. Drop your squared, put a plus or minus square root around the other side. Typically, we don't like a fraction inside of a square root, so we'll put a square root on top and square root around the bottom. Typically, we don't like a square root down denominator, so we're going to multiply the top and bottom by that square root. And when we do that, we get x is equal to plus or minus square root of 6, and then square root of 3 times square root of 3 is 3. Okay, so now we're going to build our table of intervals. We've got x is equal to -square root of 6 over 3, and x is equal to square root of 6 over 3. Clear over here is positive infinity. Clear over here is negative infinity. I have no clue what these are. Let's go to the calculator. I'm going to exit out, do second mode, and square root of 6 over 3. So second x², square root of 6, divided by 3, 0.8. Okay, so this is roughly 0.8, which means this is roughly -0.8. So choosing test cases. Choose something between -infinity and -square root of 6 over 3. -2. Something between -0.8 and 0.8, 0. And something greater than 0.8, 2. Now we want to plug those into our second derivative. Let me go back up here. Remember, our second derivative was 12x squared minus 8. Now remember where we put that on our in our calculator. If I go back to the y equals, we put 12x squared minus 8 on y3. Now y3 doesn't appear in our table when we go there though, so let me shut these other ones off. I'm going to come down here and I'm going to left arrow and see how my flashing cursor is on equals? Press enter one time and that'll shut that one off. So now if I go to my table, we do second graph, you see I got y1, which is our function, and y3, which is our second derivative. So I'll press delete, clearing those numbers out, and we're testing -2, 0, and 2. So -2, enter, 0, enter, 2, enter. And I'll look at the right column this time. y3 is our second derivative, so that's positive, 40, so it's concave up. The -8, that's negative, so it's concave down. And then this is 40, which is positive, so it's concave up. Now our POI exists where the concavity changes. So this is a POI and this is a POI. Now as weird as it seems, these come out nice. So we got POI at -6/3, comma something. And we also got one at excuse me, √6/3, comma something. Now we want to plug these back into our original function. Now remember, our original function was y1. So let me come up here, clean those out, press delete. And we want -√6, so second x squared, 6, closing parentheses, divided by 3, enter. Oh, I thought that came out nice. Oh well, I'm happy with decimal. Wonder why that didn't come out nice though. -0.22, probably because I'm asleep. Oh, I know why. And then this next one, if we put √6/3, I do second x squared, 6, close parentheses, divided by 3. And we get another -0.22. Now, like I say, I'm happy with those answers right there. If you're curious, let me do one of them by hand to show it to you. So we got x is equal to √6/3, and we're going to plug that back. Try it again, over 3. We're going to plug that back into our original function. Now, our original function was this, so we got x to the 4th, so we got √6/3 to the 4th, minus 4 times √6/3 squared, plus 2. Now, √6 times √6 times √6 times √6. Well, √6 times √6 is 6, and this gives you 6. 6 times 6 is 36. 3 to the 4th is 81, minus √6 squared is 6, times 4 is 24. 3 squared is 9, plus 2. And I'll put 2 over 1. I want to get a common denominator. So we got 36/81 minus 81 will be our common denominator. I multiply the bottom part by 9, so multiply the top part by 9. 216. So we had to make a math error. And here I multiply the bottom part by 81, so I multiply the top part by 81. That gives us 162. 54, so that's -54. Brain shutting down. Gives us -18/81. Assuming I didn't screw up. Let me double check that. -18 divided by 81. And you see we get all the 2's that we got with the POI. So that's how you do it by hand if you want to do it by hand. Again, decimal's fine there. I don't want you to spend a huge amount of time on the algebra on that. But anyway, those are answers.